To make our comet, we'll be using water, sand, some crushed charcoal, corn syrup, an ammonia-based glass cleaner, and frozen carbon dioxide, or dry ice. Comets contain a lot of frozen water. In fact, one of the explanations for how the oceans formed on the Earth is that the water was brought here by comet impacts early in the Earth's history. Comets also contain some of the same rocks and minerals that formed the planets in our solar system. The nebula that formed our solar system contains simple organic compounds. Those are molecules with carbon, nitrogen, oxygen, and hydrogen. The carbon's represented by the charcoal here. Other organic molecules found in the early solar system include simple kinds of sugars, made of carbon, oxygen, and hydrogen. On the Earth, these form the basis for more complicated molecules like amino acids found in all living organisms. Ammonia, a mixture of nitrogen and hydrogen, is found in large quantities in the atmospheres of the gas giant planets, and also in comets. We've got all of our ingredients ready, but it doesn't look much like a comet yet. Comets form at the edges of our solar system, far from the warmth of the sun, so we need to add something cold. It's time to add the dry ice. So dry ice is carbon dioxide. It's a gas at room temperature, but it freezes at minus 78 degrees Celsius. It's important to wear insulated gloves when handling dry ice to protect yourself from frostbite. At this temperature, all of the ingredients are starting to freeze together into a great big snowball, just like at the edges of our solar system where comets are created. Here it is, the core of our comet. You can see all the ingredients have frozen together into one solid object. Now you may have heard people describe comets as dirty snowballs, and really that's exactly what this is. From up close, you can see some of the water bubbling as the carbon dioxide changes from a solid directly into a gas. But this comet still doesn't look like what we see in the sky. To find out what's going on, we need to turn out the lights. So what gives a comet its tail? And why does it glow so brightly in the sky? Well, it's not on fire, but it is melting. Comets spend most of their time at the far edges of our solar system, where it's dark and it's cold and we can't see them at all. But sometimes their orbits will change, either through a collision or through the pull of a large gas giant planet, and then they'll start to travel toward the center of the solar system. As the comet gets closer to the sun, it heats up, and the solid carbon dioxide starts to sublimate, or turn into a gas, just like what we see with our comet here. This thick atmosphere of gas escaping from the comet gets shaped into a long tail by the pressure of the solar wind, a stream of charged particles that flows outward from the sun. This means that a comet's tail always points away from the sun and doesn't drag behind it as it moves. Some comets will hit the sun and be destroyed, and others will circle around many, many times, slowly melting and crumbling away, until all that's left is a trail of dust through the solar system. And this trail of dust is what forms the yearly meteor showers, like the Perseids this August.